Hello everyone, the goal of this is to give you a quick recap of inverse functions and relations. The goal is by the end of this video we remember how to find and graph inverse functions and relations, but also verify inverses. So the very first thing is this notation here, this f of x is function notation. And then the new one for this lesson is this f inverse of x. And so you see this -1 right there. That's not an exponent. What that means is inverse function. So this one is specifically stating that we are taking the inverse of f of x. So for problems number 1 and 2, we're going to find the inverse of the following function or relation. In order to find the inverse, the biggest thing you need to remember is to switch x and y. Switch your input and your output, and if applicable, then you're going to want to solve for y. So for number 1, normally you have your x and then followed by your y for coordinate points. So what we're going to do for the inverse is switch each of these, the x and the y value. And if it's a coordinate point, it's nothing other than switching those and rewriting the points. So the first point, -8, -3, becomes -3, -8. We switched our x's and we switched our y's. Same thing with the next one. It's going to become -6, -8. And our last one is going to become -6, -3. If it has something like this function notation here for this one, we're going to pretend that that is a y. And in order to find the inverse, what we're going to do is we're going to take just the x and just the y, the variables themselves. We are going to switch them. So y now is going to be replaced with an x. X now is going to be replaced with a y. Once we do that, in order to find your inverse function, we are now going to take and we are going to get y by itself. So we're going to add the 6 to the other side, and we're going to divide by 2 to get the y by itself. We have now found our inverse relation or function, but now what we're going to do is we're going to take this y and we're going to use that notation that we learned from above. So this is going to be written as f inverse of x equals 1/2 x plus 3. So switch x and y and solve for y. We're going to do the same idea now, but on a graph. So we have our original function here. It's a quadratic. The vertex here is 0, 1 because it got shifted up 1 due to the +1. So we're going to go to 0, 1. From here, we're going to go over 1 and up 1, over 1 and up 3, and over 1 and up 5 with our graphing pattern for our quadratic. You can see the parabola is a nice U shape. That is our original function. So to find our inverse function, what we're going to do is we're going to go ahead and switch x and y. Remember, f of x here means y. So we're going to replace y with x. We're going to replace x with y. And we're now going to get y by itself. So subtract 1. We're going to square root both sides. And when we square root, we're going to have plus or minus out in front of the square root. So it's going to be y equals plus or minus the square root of x minus 1. We're going to use our new inverse notation. Notice this inverse is actually not a function, but we're going to stick with the f inverse of x here. So we write f inverse of x equals plus or minus the square root of x minus 1. Now there's a couple of ways to graph this. You can remember your transformations upon square root functions, meaning it's going to move right 1 and do your graphing pattern. Or what you can do is you can say, hey, this is my inverse function. F of x over here, in fact, I'll label it here. This was my original function. What I can do is I can take all of these points and I can switch the x and the y value. So if I were to create a table of x and f of x, our points are -3, 10, -2, 5, -1, 2, 0, 1, and so forth. So what we could do is we could take this table of values and we could switch our x and our y values. So all of our x values now are 10, 5, 2, 1, 2, 5, and 10. All of our x values of our original function become our y values of the inverse. So -3, -2, -1, 0, 1, 2, and 3. Now it's just an issue of graphing this as x comma y. So 10 comma -3 is down here, 5 comma -2, and we can continue on with this method of graphing to then see what our inverse looks like. Again, here's our inverse. Again, note that it is not a function, but we're just going to stick with this notation because that's what the original problem was given in. Our last goal for today is to verify functions are inverses of each other. When you see the word verify, it is asking you to prove that two functions are inverses of each other. And in order to prove that, we need to do a composition of the functions, both g into f and f into g, and we need to show all of our operations undoing each other. So the first one, f of g of x. As a reminder, we could write it like this, f of g of x, which means we're going to take g of x, which in this case happens to be the square root of 7x minus 2, and we're going to plug it in as our input wherever we see the x in f of x. So we have the square root of 7x minus 2 squared plus 2 over 7. Now the square root and the square are going to undo each other. So that's the first thing with the inverses, that these two are inverse operations because they undo each other. We're left with 7x minus 2 plus 2 over 7. So next, the minus 2 and the plus 2 undo each other. We're left with 7x over 7. And the last thing is that the 7 divided by 7, those undo each other. So when we did f of g of f, every operation got undone, and we were just left with x. That's our goal, is to just be left with x. So now let's try the next one, g of f of x. The same thing is supposed to happen. So we're going to take f of x, and that is x squared plus 2 over 7. And we're going to use that as our input for x in g of x. So we have the square root of 7 times, our input is x squared plus 2 over 7, and then minus 2. So the first thing that cancels out or undoes each other is the 7 divided by 7. When that happens, we're left with x squared plus 2 minus 2. The positive 2 and negative 2 are inverse operations. So we're left with the square root of x squared. And the square root and the square are inverse operations. So when we did g of f of x, we just got an x back out. So therefore, g and f are inverses. If you did not get x back out, for instance, if you got x plus 1, these would not be inverses. So this was meant to be a quick recap of inverse functions and relationships. We should be able to find inverses, graph inverses, and verify two functions are inverses of each other. You should find some additional practice problems at the end of this file, allowing you some extra time to practice. The answers will be posted in OneNote. Thank you very much and have a good day.